Today, we will look at fractions under a brand new series called Fractions, Decimals, and Percents. In this chapter, we will look at understanding fractions, manipulating fractions, switching between improper fractions and mixed numbers, division in disguise, fraction operations, comparing fractions, and instances when never to split the denominator, benchmark values, when to pick smart numbers, and when not to use smart numbers. Now, a fraction is a small or tiny part of something which is written as x over y, with x being the numerator and y being the denominator. We will examine the two circles here and try to use them to help us to understand how fractions work. Fractions basically divide units into parts. The units above have been divided into 4 equal parts because the denominator of our fraction is 4. Now, in any fraction, the denominator tells you how many pieces or how many equal pieces a unit has been broken into. The circle at the top, this particular one, has three shaded quadrants and one unshaded quadrant. So the shaded portion makes up the numerator. For any fraction, the numerator tells you how many of the equal pieces you have. So, for example, if we assume that the circle represents a cake, which has been divided into 4 parts, and we say 3 equal pieces goes to customer A, and the remaining piece goes to customer B, we ask the question, what fraction will go to customer B? So here, essentially, if these 3 pieces, shaded portion, goes to customer A, and then this 1 piece goes to customer B, then it means out of the 4 pieces, customer B gets 1 piece, and then the fraction will be what? 1 over 4. And the fraction that goes to customer B will be 3 over 4. Let us turn our attention to proper fractions. A proper fraction is less than 1. Okay, a fraction which is less than 1, with the numerator less than the denominator. So you have half being a proper fraction, because if you examine the numerator, it is less than the denominator. Let us look at a few rules under fraction. As the denominator of a fraction gets bigger, the value of the fraction gets smaller. So you see this example here, starting from this fraction, with the numerators being the same. Realize that 4 over 5 is greater than 4 over 6. As the denominator increases, the fraction, the value of the fraction will reduce. So this fraction is bigger than this fraction, and 4 over 6 is also bigger than this fraction, which is 4 over 7. Rule number 2. As the numerator of a fraction becomes bigger, the value of the fraction becomes bigger as well. So here you see this example starting from 1 over 4. All the denominators are the same, 4, and the numerators are increasing from 1 to 3 to 4 to 5 to 13, and you can tell from here that 1 over 4 is smaller than 3 over 4, and 3 over 4 is smaller than 4 over 4, and 4 over 4 is smaller than 5 over 4. And so here we've established that as the numerator of the fraction gets bigger, the value of the fraction becomes bigger. Now let us look at improper fraction. An improper fraction has the numerator larger than or equal to the denominator. So here you realize that 4 over 4 is 1, and fractions and proper fractions are fractions that are less than 1. Okay, so because 4 over 4 is 1, then this one is what? an improper fraction. Now 5/4, you can tell from the definition of a proper fraction that the numerator must be less than the denominator. So you can tell that with these two fractions, 5/4 and 13/4, the numerators are bigger than the denominators, and therefore they do not qualify to be proper fractions. They are called improper fractions. Now let us look at these examples here. It says that for each of the following sets of fractions, decide which fraction is larger. Now you have 3/7 and you have 2/7. The denominators are the same, and therefore looking at the numerators, you realize that this is 3 and this is 2, and therefore this fraction is bigger than this fraction. Now here we have, in reverse, the numerators are the same and the denominators are different. And so here, if you look at this fraction and this fraction and then this one, you realize that this is bigger because this fraction has a denominator that is larger, and dividing the numerator and then making this the value of this smaller. Now try these two examples here. Let us turn our attention to manipulating fractions. In this section, we will look at how to add, subtract, multiply, and divide fractions. We will begin with how to add and subtract fractions. For example, if you have 4 pieces out of a 7-piece cake, and your friend gives you a piece out of the 7-piece cake, what is the total fraction of cake you have? And we are using this to represent this scenario. So you have 4 pieces out of 7 and your friend gives you 1 out of the 7. Essentially you have 5 out of the 7-piece cake. Now let us look at a second scenario where you have 4 pieces out of a 7-piece cake and you owe a piece to a friend. What is the total fraction of cake you have left? So you have 4, you take 1 out, you give to a friend, you have 3 out of the 7 left. Now essentially, if the denominator of the two fractions are the same, the denominator will be the same. After adding or subtracting, only the numerator will change. And so if you look at these scenarios that we've looked at, 4/7 plus 1/7, the denominator will be the same, and then all you have to do is to add the numerator, 4 plus 1, and you have 5. Same with 4/7 minus 1/7. The denominator will not change, but you will subtract 1 out of 4 to get 3. So very, very. Now, if the denominator are different, you can try to make the denominator the same to help you simplify. Now, in order to do so, we have to find a common denominator. So you have 1/2 plus 2/3. Here, these are the two original fractions. Now, in order to make the denominator the same, we can multiply this fraction, by 3/3. And then this particular fraction here by 2/2. So that here 3 times 2 gives us 6, and then 3/2 gives us 6. And then we have a common denominator. Now, multiplying these fractions by these placebo fractions. Now, I call these fractions placebo fractions because they do not have any effect. 3/3 is essentially 1. So multiplying 1 by half is half. 2/2 is also 1. Multiplying 1 by 2/3 is 2/3. And so I say that multiplying the fractions with these placebo fractions will only help you manipulate and simplify the fractions, and will not impact the integrity of the solution. And so here you have what, 3 over 6, and then here you have 4 over 6. So because the denominators are the same, 6 and 6, you can simply add the numerator of the two fractions. So you have 3 plus 4, and then here you have 7 over 6. Now try this. Evaluate the following two examples. Now let us look at how to manipulate fractions under multiplication and division. Now whenever you are solving multiplication or division problems, both the numerator and the denominator typically change. Okay, so here in this example you have 4 over 3 times 2 over 5. All you have to do is to just multiply the numerator, 4 times 2, you have 8, and multiply the denominator. So you have 3 times 5, which is 15. So very, very simple stuff. Okay. Now in this second problem, we have two dividing fractions. Now we can rephrase two dividing fractions to become a multiplication problem. Here you have 4 over 3 divided by 8 over 7. Now here, to transform this into a multiplication problem, you can switch the positions of the numerator and denominator of the right side fraction. This one. And so here it becomes 4 over 3 times 7 over 8. You flip it. Flip the numerator and the denominator. And then you change the sign. So the sign will become multiplication. And then you simplify. Very simple stuff. Whenever we multiply fractions, we should always look to cancel common factors to reduce our answer without doing unnecessary work. Let us look at this example. 33 over 5 times 15 over 3. We could use the long division method to multiply, the numerators and then multiply the denominators, which leaves us with 495 all over 15. And then we can proceed to use the long division method. So here, using the long division method, this is what we have. We have 15, and then you have 495. Now 15 will go into 49. 3, you have 45, and then you have a remainder 4, and then you have 5. 15 will go into 45, 3, then you have 45. Okay, so here the answer is what? 33. Now this problem can be simplified greatly by cancelling part of each fraction before multiplying. Now we always have to look for common factors in the numerator and denominator. So instead of the long division method, we can break down the numbers using prime factorization. And so here you can rewrite this as 33 over 5 times 15 over 3, which is equal to what? 3 times 11 all over 5, and then 5 times 3 is 15 all over 3. Okay, so here clearly you can see that this 3 can cancel out this 3, then this 5 can cancel out this 5, and then you have what? 11 times 3, which is what? 33. So here, this is very simple stuff. It's better to do this than to multiply 33 by 15, arrive at 495, 563, arrive at 15, before you come and do long division to arrive at 33. Try to evaluate this example right here. Now let's look at fractions in equations. Now when a variable x appears in a fraction, multiplication or division problem. We use essentially the same concepts and techniques we have already looked at to solve. Now you have 2 over 5x is equal to 8 over 5. Now to let x stand alone, we can divide this side by 2 over 5 and then this side by 2 over 5 to arrive at this. So you have x is equal to 8 over 5 divided by 2 over 5. Okay, we can switch this division problem into a multiplication problem by switching the position of the numerator and denominator of the right hand side fraction. And then after we switch the position, we can change the sign or the symbol from a division symbol to a multiplication symbol. So here 5 will divide 5, and then we can say that 8 divided by 2 is 4. So very simple stuff. Try your hands on these two examples. We'll turn our attention to switching between improper fractions and mixed numbers. Now, an improper fraction is a fraction where the numerator is greater than or equal to the denominator. A mixed number is a number consisting of a whole number and a proper fraction. So if you look at this definition right here, you realize that improper fraction here we have a over b, and then a is greater than b, and then you have here a mixed number is where you have a whole number and a proper fraction where b is less than c. So let's look at this example right here. You have 17 over 5, which is an improper fraction. We want to turn this into a mixed number. So here you have 5 will go into 17 3 times. Okay, so 5 3 is 15. Remainder 2. Okay, and then 2 over 5. And so you realize that this becomes 3 whole number 2 over 5. And then this is the mixed number, and this is the improper fraction. So here we can turn this mixed number right here back to, an improper fraction. So this from here to this, and then this is how we go through the solution. So here you have 3 whole number. This is the 3 plus. Essentially, this is this plus this, is the same. You're saying that 3 2/5. Okay, 3 plus 2 over 5. Okay, so we can break it down and say 3 plus 2 over 5. And then here, essentially, we can put 5 over 5 here, which is a placebo fraction. It doesn't really change the integrity of our solution. So you put 5 over 5 here, which is essentially 1. And then here, 3 over 5, 3 times 5 is 15. And you have 15 over 5, and then plus 2 over 5. 15 plus 2 is 17 over 5. So you realize that we moved from this improper fraction to this mixed number, and we moved from this mixed number back to this improper fraction. So very, very, very simple stuff. Try your hands on these two. We will look at division in disguise. Sometimes dividing fractions can be written in a confusing way. You must be aware to avoid being tricked. So you have w over x all over y over z. So w over x can be written as this, w over x divided by y over z, and then you can turn this into a multiplication problem by switching the position of the numerator and the denominator of this fraction right here. And then we have a typical example, 3 over 5 all over 2 over 3, and then it becomes this 3 over 5 times 2 over 3, and then you can turn this into a multiplication problem, switch the position, change the symbol to multiplication, and then boom, you have 9 over 10. Try your hands on these two right here. Now let's turn our attention to fraction operations. Now, adding or subtracting fractions leads to expected results. We know that when we add two positive fractions, we get a larger number. And when we subtract a positive fraction from a number, we get a smaller number. However, multiplying or dividing by fractions yield unexpected results. Multiplying by, a proper fraction or a number between 0 and 1 creates a product smaller than the original number. So let's pick a number, say 14. And let's multiply 14 by a proper fraction, okay, which is 6 over 7. You realize that, the resulting solution is smaller than, the original number we began with. You see, so 12 is less than 14. Okay. And similarly, we can also look at pure fractions. 3 over 4 times 2 over 3. Multiplying this number 3 over 4 times 2 over 3, and then we arrive at half. Okay. And here in this situation, you realize that half, is what? Less than 3 over 4. Okay. So you realize that whenever you multiply a number, it doesn't matter the number, by a proper fraction, you get a solution that is less than the original. Similarly, when you divide by a fraction between 0 and 1 or by a proper fraction, the result or the quotient that you get is larger than the original number. This is also true when the original number is a fraction. So here we have 14 and then we are dividing by half. Then you realize that your result is 28 and 28 is larger than the original number. Same here, 3 over 4 divided by half, you arrive at 3 over 2, and 3 over 2 is bigger than 3 over 4. Okay, so take note of these results and let it be at your fingertips, so that on the exam there are instances where you do not have to calculate. Because of these rules, because of the fact that you understand proper fractions, you will be able to see things that other people will not be able to see. Try your hands on these two examples. Now, comparing fractions. Okay, here we have this example here. It says which fraction is greater. Now, the shortcut to comparing fractions is by cross multiplying. This involves, multiplying the numerator of one fraction with the denominator of the other fraction and vice versa. So you have this particular fraction here, 6 over 7, and then you have 5 over 6. And we are asking which one is bigger. So you multiply this denominator here by this numerator, and then you multiply this denominator by this numerator. Now remember to put each answer by the corresponding numerator, not the denominator. So this one moves to multiply here, and this one moves to multiply here. So at the end of the day, here you have 36, and then here you have 35. Then you say 36 is bigger than 35, and so this fraction here is bigger than this fraction. Okay. Now the reason why you move the denominator to multiply by the corresponding numerator and the result will stay here, and you move this one and the result will stay here, is so that you don't confuse the positions of the fractions. Because if I move this numerator to multiply here, you are getting something completely different. So if I move this to this side and I have 35, and I move this to here and I have 36, you may say that this is bigger. So you have to be careful of how you move, the numbers. The denominators will move to multiply and remain. So 6 will move here and remain here. 7 will move here and remain here. And then here is 36 and here is 35, and this fraction is bigger. Now, which fraction is greater? Let's try this example here. Here, similar stuff. Okay, 7 will move and multiply 2. So 7 times 2, and then 13 will move and multiply 1. 1 times 13. This is 14, this is 13, this is larger. So this fraction is bigger than this fraction. Try your hands on these two examples. Now let's just turn our attention to situations where you should never split the denominator. Now, one rule when working with fraction is to always remember how to manipulate fractions that have more than one term in the numerator or denominator. Now, there are 3 scenarios here where we are going to, determine whether we can split the numerator or denominator or not. Okay, so here in this scenario you have a plus b over c, you have a over b plus c, and you have a plus b all over c plus d. Now in the first scenario, a plus b, yes, we can split the numerator, and so you have a over c plus b over c. Now in the second scenario, a over b plus c is not equal to a over b plus a over c. You cannot split the denominator, and so this is a no. A plus b all over c plus d. Here, similarly, you cannot split the denominator, and so this is also a no. However, there's a way we can write this. We can split the numerator. So we could say, in this instance, we could say a all over c plus d plus b all over c plus d. Now, you cannot split the denominator, so it always has to, the whole thing has to go. You can't, however, split the numerator. So if you split the numerator, okay, and a stands alone, you have to divide by the entire denominator, which is c plus d. Same with this, b plus c, b all over c plus d. So this is correct, but this is wrong. So try your hands on these 2 examples here. Now we turn our attention to benchmark values, and here we're going to learn how to see numbers and approximate. Now we can use benchmark values to estimate fractions or approximate fractions. Now these are simple fractions you may already be familiar with, and we have 1 over 10, 1 over 5, 1 over 4, 1 over 3, 1 over 2, 2 over 3, and 3 over 4. Now we can use benchmark values to compare fractions. Okay, so we have this example right here, and it says which is greater, 123 over 250 or 163 all over 320. Now if you see this question on the exam, remember you cannot use the cross multiplication rule to solve. There is a different technique. Now if we recognize that 123 is less than half 250 and 162 is more than half 163, is more than half 320, we will save ourselves a lot of cumbersome computation. Now, to look at this intuitively, you can see that half of 250 is what? Is 125. So let me write it down. 125 all over 250 is what? Half. But 123 is slightly less than 125. Okay, you have 1, 2, 3. Slightly less than what? Half. Also, we know that half of 320 is 160. Okay, so we can say 160 all over 320 is what? Half. Okay, but 163, okay, is slightly more than 160, and so the value of 163 over 320 what will be slightly more than half. Slightly more than half, which makes, you know, the fraction 163 over 320 slightly bigger than what? 123 over 250. So we didn't do any computation. We just looked at the numbers. Okay, and then you can tell that both are approximately, you know, close to half, but one is slightly bigger than half and one is slightly less than half, and then we use this to determine which one is bigger. Now let's look at example 2. Approximately what is 10 over 22 of 5 over 9 of 2,500. Now here, if we can recognize that these fractions are very close to half, we can estimate. So here we can approximate this 10 over 22 to be half, and then 5 over 9 to be half, and then times what? 2,500, and you can say this is 625. Approximation, you know. And so one thing that is key when you're solving this type of question is to make your rounding errors partially cancel each other out by rounding some numbers up and others down. So here, if you look at this particular, you know, it's 10 over 222 is slightly less than half, and 5 over 9 is slightly more than half. Okay, we round this, you know, up, and then we round this down. Okay, and multiply by 2,500, and you get an approximate number, which is 625. Try your hands on these two examples, then we move on. Now we look at instances where we pick smart numbers. Now, sometimes you can see questions on the test which include variables that are unspecified. This means you simply do not have real figures to deal with, just variables. What do you do in such scenario? Now, to make computation easier, you have to choose smart numbers equal to common multiples of the denominators of the fractions in the problem. Now let's look at this example right here. It says that the Lamtes have 2 water tanks, one painted blue and the other red. The red tank is halfway filled. The blue tank, which has a capacity 3 times that of the red tank, is filled to 4/5 of its capacity. If the red tank is drained into the blue tank, to what fraction of its capacity will the blue tank be filled? Yeah, so here we have, you know, 2 tanks, the red tank and the blue tank. And then we can say that the fill, and then here will be what? Capacity. And we know that the red tank is halfway filled, half, you know, capacity is X. Blue tank is 3 times the capacity of the red, and it is filled to 4/5 of its capacity. Yeah, so this is what we have right here. And so if we pick 100, okay, say the capacity of the red tank is 100, X is 100, we can easily say the capacity of the blue tank is 3 times 100, which is what? 300. And then here we can say if this is halfway filled, then this X here is what? Put 100 here, and then you have what? 50. Okay. And here you put 300 here, you have what? You have 4/5 times 300. 5 will cancel this. 60. 6 times 4, so you have 240. Now you have 240 if we put this, if we drain, you know, with the water in the red tank into the blue tank, you have 240 plus 50, which is what? 290. It says that if the red tank is drained into the blue tank, to what fraction of its capacity will the blue tank be filled? So here you have the fill of the blue tank, which is now, because we drained the red tank into the blue tank, which is 290 all over what? 300. And then you have what? 29/30. Simple stuff. So here you realize that we picked a number, smart number, which is 100, which helped us to be able to what? Solve this question. Very, very simple stuff. Now try your hands on this particular example. He says Sophie's USB flash drive is filled to have capacity with movies. Her USB hard drive, which is 3 times the capacity of her flash drive, is filled to 4/5 capacity. Will Sophie be able to transfer all of her movies from her flash drive to her hard drive? Let's try and solve this question. Here we will look at a situation where we do not pick smart numbers. In some problems, an unknown amount may actually be specified in the problem in another way. In these cases, you cannot use smart numbers to assign real numbers to the variables. Let us look at this example. Now it says that John has a huge basket, 1/4 of which are mangoes and 5/8 are pineapples. The remainder consists of apples. If John has 75 apples, how many fruits does he have in the basket? So here we can simple stuff. So we are looking at fruits, so we can say 1/4, you know, of fruits, what are mangoes, and then we can say 5/8 of the fruits are pineapples, and then we can say the remainder consists of what? Apples, and the apples are what? 75 apples, and then all these must be equal to the fruits. Okay, so very, very simple stuff. And so what we can do is to, you know, take all the variables to one side. We can say 75 is equal to, you know, here f minus 1/4 f minus 5/8 f. Okay, f for fruit. Now you have 75 is equal to, so we can find a common denominator, and so here is only f. We can say 8, use a placebo fraction, 8/8, and then here you have what? You have 1/4. We can change here to what? 2/8 by multiplying 1/4. So you multiply 1/4 by 2/2, and then you get what? 2/8. 2/2 is a placebo fraction, remember. So you have 2/8f minus 5 all over 8f. Okay, so here you have a common denominator for all your fractions, and then you have, so 8, and then you have what? 8f minus what? 2f minus 5f. Okay, so 75 is equal to 8f minus 7f all over 8. And you have 75 is equal to 8f minus 7f is what? F all over 8. Okay, and so here you have f is equal to 75 times 8. So here you have f is equal to what? Very, very, very simple stuff. So here we did not pick any smart number. There's another way you can look at this. Here we can say, okay, we have 1 over 4 mangoes, and then we have 5 over 8 pineapples. Okay, and then we have apples. Okay, here what we could do is to say add these two mangoes and pineapples. You have 1 over 4 plus 5 over 8, and we can use a placebo fraction to make the denominators the same, and then this one gives us what? 7 over 8. Okay, so 7 over 8. Clearly, we have a remainder plus apples should give you what? 8 over 8, which is the whole. Okay, so clearly here you have 7 over 8 plus 1 all over 8. Okay, and so this 1 over 8 here is what? Is apples. 1 over 8 is apples. Okay, and then we can say that 1 over 8 times the fruits should be equal to what? 75, and then we can say fruits should be equal to 75 times 8, and then we can say fruits should be equal to what? 600 fruits. Okay, so that's another way you can look at this problem. Try your hands on this particular question. Says Meg spends 1/3 of her waking hours in schools, 1/5 of her waking hours eating, 3/3 of her waking hours playing video games, and 2 hours going to and from school. She engages in no other activities while awake. How many hours is Meg awake? Very interesting question. And this brings us to the end of fractions under the fractions, decimals, and percents series. See you in the next video.